Hello everyone, welcome back to the channel. So in this video, we'll be calculating height of the binary search tree. Okay. Now we are going to again use the recursion technique to do the same thing. How do you calculate the height of the binary search tree? Okay. So let's say you have a root node, right? And then there are two childs of it. Okay. Left child and right child. So you are going to consider that tree height as 2. Okay. That is the max height of the tree. And if let's say one of the node on the left side has another left child, okay, then the height of the tree will become 3. So if there is any single root in the tree, okay, which is root node, we are going to consider the height as 1. So considering that logic, we are going to implement this method. So let's implement this. I have this tree dot height, the method that we haven't implemented yet. Let's go ahead and implement that method. We are going to implement, so this method is going to return integer. Okay, to iterate in our tree we need the root node obviously, so that's why we have to create that method with the root node argument. Let's create that method now, which is going to return integer. Yes, this is a root node. And now what this method has to do, okay, let's think about some scenarios. Okay, so first scenario would be if root is equal to null. That means you have an empty tree, there are no nodes, then the height would be 0, right? There are no nodes, so there is no point of having any height, so that's why we are returning 0 here. Okay, now let's talk about another scenario, which is actually also a base condition. Okay, so when you are iterating through your tree, right, and you reach to your leaf node, so leaf node has no left child, no right child, right? So in that case, you're supposed to return 1, because as you discussed earlier, single node height is 1. Okay, so let's implement that. If root dot left child is equal to null and root dot right child is equal to null, we are going to return 1. Okay, let's say you have one root node. Okay, then this root node has one right child. Okay, and there are no childs of this particular right child, and you have a left child. Okay, and you have one more left child of this particular node. Okay, so in this kind of scenario you are going to consider the maximum of the height. Okay, so how you are going to consider the maximum? Let's write the logic for that. Math dot max of whatever is the height of left child and the height of right child. Okay, so whatever is the maximum of this, right, in that we are going to just add 1 there, and we will get the height of a complete binary tree. Now I guess we are done with the implementation. Let's try calculating. Let's try running the method and see if we are supposed, for this one we are supposed to get 3. I guess we are getting 3, because if you consider this, right, let's say you have 7 as a top root node, then you have 4 which is less than the tree. Okay, less than the root node, and then you have 9 which is greater than the root node, and then you have 1 which is even less than the 4. So that's how, you know, we already got that 3 height already, right? So this will be added in the same height positions. Okay, so we can say, and also you can just take this tree and consider the rules that I have shared with you for creating binary search tree, right? The height that you're going to get in this case is 3 only. Okay, so this is the height of the tree. So that's all I wanted to cover as part of this video. See you in the next one. May the source be with you.